Okay, welcome to the third video on balancing equations. So what I have for you is six word equations that I'm simply going to say, and as I'm saying them, I want you to try to convert them um, to chemical equations. All right, and I'll give you a minute, and then I'll show you the correct chemical equation, and then I'll give you a moment to try to balance it, and then I'll show you how it's balanced, and then we'll identify the reaction type. So by the time we get done with these six problems, this should be a pretty good workout. Okay, so the first one is, all right, so number one, and I'm just going to say the reaction. Hydrogen gas reacts with molecular iodine to form hydrogen iodide. So again, that's hydrogen gas reacts with molecular iodine to form hydrogen iodide. Okay? Alright, so you can push the pause button, work it out. Okay, so here's the solution. So hydrogen gas, that's a diatomic, so that's H2, plus molecular iodine. Alright, iodine is one of the diatomics. Reacts to form hydrogen iodide. All right. Now, this is what type of reaction does that look like to you? Yeah, if you said synthesis or combination, you're correct. And balancing this equation is actually pretty straightforward. You can just use one coefficient. You put a 2 here, and so now we have two hydrogens on both sides, two iodine atoms on both sides, and so now we have a balanced equation, and we're obeying the law of conservation of matter. So everything is good. Okay, good. So if you did that correctly, good job. All right, the second one. So I'll read the equation for this. Carbon monoxide, that's carbon monoxide, reacts with molecular oxygen to form carbon dioxide. Okay, so you push pause. Okay, now carbon monoxide is CO plus molecular oxygen, O2, and that forms carbon dioxide. All right, there we go. So what kind of a reaction does that look like? If you said combination, you are correct. So we're taking two molecules, two different compounds, and they are combining to form carbon dioxide. All right, now we got to balance it. Well, the carbons look fine. We got one carbon on both sides. So it looks like, and by the way, you please pause and try to balance this yourself before I give you the solution. But here's one solution. So you have 3 oxygens on the left, 2 oxygens on the right. So there's no way around it. You're going to have to put a coefficient in front of the carbon dioxide in order to boost the oxygen count. Okay, so let's start with a 2. All right. So now we have 4 oxygens on the right and 3 on the left. But if we put a 2 here, then we have, if we make a tally, we have 2 carbons on the left, 2 carbons on the right, and we have 2 oxygens plus these 2 oxygens. That's 4 over here. 2 times 2 is 4, as we said. And there you go. That's the balanced chemical equation. 2, 1, and 2. Okay, great. Now let's let me try to, can I select? I guess I got to use my erase tool here. Bear with me. Still getting the hang of the drawing pad. Okay, number 3. Number 3. Here's the chemical reaction. Elemental sodium reacts with water to form sodium hydroxide and hydrogen gas. So again, that's elemental sodium plus water reacts to form sodium hydroxide and hydrogen gas, or molecular hydrogen. Alright, so see if you can write that equation down. Meanwhile, I'll be erasing over here. Okay. Alright, so here we go. That's sodium. Okay, elemental sodium is just pure sodium plus water. And we actually did this as a demonstration in class. We cut a piece of sodium metal, dropped it in water, and watched it turn on fire. Sodium hydroxide plus molecular hydrogen, or hydrogen gas. All right. Now, what reaction type does that look like to you? If you say looks kind of like a single replacement, you're absolutely right. Sodium is kicking out the hydrogen here and replacing it to form sodium hydroxide, and then the hydrogen is, or most of the hydrogen anyway, is going into molecular hydrogen. Okay, so what looks like it may be out of balance here? Well, you've got one sodium on each side, you have one oxygen atom on each side, so those are fine. So it's the hydrogens that are the problem, right? You got two hydrogens here, 1 plus 2 is 3 over there. So clearly we're going to need to increase the hydrogen count. So let's put a 2 here. We'll start with a, start with a 2. And so now we have 4 on the left, only 3 here, so let's put a 2 here. Alright, so now the, let's see here, I feel like I made a mistake. No, I think we're okay for now. 4 hydrogens on the left, 2 hydrogens coming from the sodium hydroxide, 2 from molecular hydrogen, so hydrogens are balanced. 2 plus 2 is 4. We have 2 oxygen atoms on the right, 2 oxygen atoms on the left. The only thing that's out of whack now is the sodium, right? We have 2 sodiums on the right, got to put a 2 here. And if I'm not mistaken, I think that's a balanced chemical equation. All right, very good. Okay, halfway there. Number 4. One moment, just need to keep track of my time. YouTube only lets you upload up to 15 minutes. Okay, fourth reaction. Here's the name. Make sure you've got your, I hope you have your polyatomic ion table at the ready. Okay, potassium chlorate decomposes to form potassium chloride and molecular oxygen. Okay, so one more time, that's potassium chlorate decomposes to form potassium chloride and molecular oxygen gas. Okay, so try to write that down. Okay, so here we go. Potassium and the chlorate, polyatomic is ClO3, decomposes to form potassium chloride plus oxygen. Okay, oxygen gas. Very good. So that is a, when I said decomposes, I guess that was a pretty good clue that this is a decomposition reaction. Now, let's take a look. Potassium and chlorines are balanced. It's the oxygens that are the problem. So you have a 2 over here, 3 here. This, the technique in this case is to use kind of a variation on the crisscross. So since you have 3 over here, let's put 3 coefficient there. You have 2 here, let's put a 2 there. All right, and see what happens. So now I think you can see that the oxygens are balanced, right? You've got 2 times 3 is 6 oxygens on the left, 3 times 2 is 6 oxygens on the right. So we did good there. But in the process, we doubled the potassium and chlorine counts over here on the left, so we got to do the same here. And now, bingo, we got ourselves a balanced chemical equation again. All right, we are booking. All right, number 5. Got 2 more to go. hang in there. Okay, so here's the word equation. Elemental aluminum, or I could say aluminum metal, reacts with sulfuric acid to form aluminum sulfate plus hydrogen gas. Again, that's aluminum metal reacts with sulfuric acid to form aluminum sulfate plus hydrogen gas. Alright, push the pause button if you if you need to go look up sulfuric acid, please do that. Okay, here we go. Aluminum metal, so that's just Al, or elemental aluminum, reacts with sulfuric acid, that's H2SO4, to form aluminum sulfate plus hydrogen gas. Okay, and notice I need a 2 subscript with aluminum and a 3 on the sulfate because aluminum, the aluminum cation is 3 plus, sulfate anion 2 minus. Okay, what kind of a reaction does that look like? If you say single replacement, you are right. So hydrogen is kind of like the Jennifer Aniston of this reaction. Alright, so the first thing, well, let me make a little tally here, just to stay organized. Okay, so like I said in class today, treat the sulfate as a unit, alright? And then we'll have hydrogen down here. Alright, so we have, first thing that jumps out is the aluminums, right? So we have 2 on the right, 1 on the left, so let's put a 2 there. Now, we've got only 1 sulfate group on the left, but we've got 3 over here on the right, so I'm going to put a 3 there. So now, let me catch up with the tally here. 2 aluminums on both sides, 3 sulfates on both sides, and now let's take a look at the hydrogens. We have now 6 hydrogens on the left. How many on the right? Only 2. But we can very easily rectify that by putting a coefficient of 3 here, bringing us to a balanced chemical equation. Okay? Very good. Now, let me clear some space. Sorry, I'm going to have to delete this to put my 6th one on. I'm going to have to go a little bit fast to make my time limit. That is nickel. Oops. Sorry about that. Let me read the equation. I got in a rush there. Okay, nickel, and that's nickel 2 nitrate plus sodium hydroxide yields nickel 2 hydroxide plus sodium nitrate. So again, that's nickel 2 nitrate plus sodium hydroxide yields nickel 2 hydroxide and sodium nitrate. Alright, I'm running a little short on time, so I'm going to go a little bit fast. Here is the equation. So that's nickel 2 nitrate, so I'm going to have 2 nitrates, plus NaOH, that's sodium hydroxide, yields nickel 2 hydroxide plus sodium nitrate. And now try to balance it. Go ahead and push the pause button. I've got 15 more seconds. The balanced chemical equation has a 2 there and a 2 there. And there you go. That's balanced. Okay, I got to sign out to make my time limit. Alright, hope that helped, and have a great evening. See you tomorrow.